Just as we examined the effect of the key variables that regulate acid-base status on hydrogen ion concentration, we could just as easily look at hydroxyl ion concentration and bicarbonate. As bicarbonate is often measured clinically, let's look at its behavior. It's easy to calculate bicarbonate ion using the non-log form of the Henderson-Hasselbalch equation. Again, we won't show its calculation, but only its behavior. We will show how bicarbonate ion concentration changes as we sweep CO2 from low to high values, in other words, from hyperventilation all the way through to respiratory failure, passing through the normal physiological range. Again, we'll fix total proteins at 70 grams per litre, these are our weak acids, and we'll plot the curve for a range of SID values. Notice how as we sweep carbon dioxide, the bicarbonate concentration rises very slightly. In other words, bicarbonate ion concentration is very insensitive to respiratory effects. Some textbooks even claim that it does not depend on CO2 at all, but as you can see, this is not quite true. Now, as we increase SID, with each successive curve we see that we increase the bicarbonate ion concentration, which remains only slightly sensitive to CO2, but of course, as each curve shows, very sensitive to the metabolic component, which in this case is SID. You may want to think about how weak acids will affect these curves when SID is held constant.